So here we're looking at Unit 5 and the Super Bowl. So we've got a simple random sample of 430 Americans, and 271 of them said they would rather go to the bathroom during the game than miss a commercial. And so that gives us a p-hat of 0.63. So 63% of people in this sample said that they would rather miss the game. Okay, so a different group, and this was in the article that was attached to this paper, found that 58% of viewers would prefer to go to the restroom during the game. So we want to know, is the proportion actually different? So we've got a hypothesis test here. So the null is that the proportion is exactly what we thought it was. And the alternative would be that it's something different, something more exciting. All right, so we usually go through and check conditions, but I'm trying to keep these videos short. So I'm going to trust that you know how to do that and just jump right into what your calculator or calculations would give you. You get a z-score of 2.11, which returns a p-value, not sure why there's an equal sign there, a p-value of 0.035. 0.035 is less than our alpha level, 0.05. So when the p is low, we'll reject the hoe. So let's write our conclusion. Our conclusion will state that we reject the null because p is less than alpha, or 0.035 is less than 0.05. So we have sufficient evidence that the true proportion of people who would rather miss the game is different. I'm going to go ahead and copy our context so I don't keep typing it. Okay. Explain what the p-value means in context. So our p-value, 0.035, that's the probability of seeing a sample that unusual. So if the true proportion of people who would prefer to use the restroom during the game is 0.58, then there's a 3.5% chance we would see a sample proportion of 0.63 or more unusual. Okay, so if the null is true, what was the probability that I took a sample of 430 people and 271 of them would say they agree with that? Okay. Our confidence interval, just like with part A, I'm going to assume that you know how to do the condition checks, but I'll confirm that when I look at your posters on Tuesday. So the confidence interval you should have come up with is, and give or take a little bit for your rounding possibly being different than mine, but I got about 57% to 68%. So I'm 98% confident that the true proportion of people who would rather miss the game than a commercial is between 57% and 68%. Well, hold on. That contradicts my conclusion up here. I said I did have evidence that the true proportion was different, but down here, 58 is in my interval. So yes, we've contradicted ourselves. 58% is in the interval. So here we would fail to reject. So how can that be? Well, if we're paying attention, this was a 98% confidence interval. Does that match up with a 5% significance level? The answer would be no, because otherwise we would have gotten the same conclusion. So what level of significance would match a 95% confidence level? So if I conduct a 95% confidence level, then these rejection regions out here, these shaded parts, because it's a two-tailed, so I was saying P not equal to, this gives me a significance level of 5%. So a 95% confidence interval, the conclusion from here would match this conclusion right here. But a 98% confidence interval has a different significance level. Okay, so 98% stretches out a little bit farther. So this would have a alpha level of 2%. So I failed to reject at a 2% significance level, which is kind of an awkward significance level, but that's what it would be. And I reject at a 5% significance level. Okay, so explain type 1, type 2, and power in context. Okay, so type 1 is we reject, but we shouldn't have rejected. So what does that look like with the context? That's us saying the proportion of people who would prefer to use the restroom during the game is different, but it actually isn't. Type 2 says we don't say the proportion of people is different, but it actually is. And power is the probability that we say the proportion is different, and it really is. So that's, we reject the null, and that was the correct decision. So we reject when we're supposed to reject. Okay, so if there's a hypothesis test with a 10% significance level, how does that change everything? So that 10% significance level, if we just sketch a little picture, means that I have 5% over here and 5% over here. Well, in this example over here, I had 2.5% and I had 2.5% for a total of 5%. So I just increased that shaded region by quite a bit, right? So my previous rejection region might have been about here and maybe here. Well, I just upped it to 10%, so now I've got 5% over here and 5% over here. So that means I'm going to reject the null more often. So type 1 goes up. Type 1 is alpha. So whatever alpha does, type 1 does the same. So type 1 goes up, alpha goes up, or vice versa. Okay, type 2, we're going to see that go down. And power, anytime type 2 goes down, power goes up. These two are inversely related, and we'll see that in this next part. So part H, if we take a sample of 621 Americans, so now our original sample size was 430. So N has gone up. In general, as you increase your sample size, we see better results. Just a very general piece of statistics. So if N is going up, power goes up with it, because power is a good thing. We like power. Now, if we think of power as 1 minus beta, then that means type 2, because type 2 is beta. As this number gets bigger and bigger and bigger, that means beta must be getting smaller. Okay, now what's type 1 doing this whole time? Type 1, if we remember from 30 seconds ago, is alpha. So what did our problem say alpha was doing? Alpha was staying the same. So type 1, that's a 1. Okay. Part I, so now we've done 2 new studies, or 1 study, 2 new samples, and we've got males and females. So I'm going to denote that, what I think is pretty logically, as P sub M and P sub F. Okay, P sub M, oops, let me not write that. Okay, P sub M I can calculate by taking 472 out of 800, and I get 0.59, and P sub F is going to be 0.534. Okay, so the difference between the percentage of women and the percentage of men who would prefer to miss the game, we would find that by just doing P sub M hat minus P sub F hat. And so this gives us a difference of 6.4%. So I'll write out what that difference means. That difference means men are 6.4% more willing to miss the game than a commercial. Than women would be. Just clarify that. Okay, so men are 6.4% more willing to miss the game to use the bathroom than women would be. Okay, well, is that a big deal? Is 6.4% something that's interesting? Well, I don't know. That could have just happened by chance, but how probable was it given these specific sample sizes? So to answer that question, we'll run a hypothesis test. So I believe nothing interesting is going on here. These two proportions are the same. But what if there is a significant difference? So significant difference is going to mean two-tail. All right? And so again, I'm going to trust that you guys know how to plug things into your calculator using a two-proportion z-test. Okay? And so you should end up with a test statistic of 2.05 and a corresponding p-value of about 0.04. I'm doing some rounding here. Okay, so if this is your basic 5% significance level, I'm going to reject the null because that's a pretty small p-value, and we'll talk about the interpretation of it after we write our conclusion. So our conclusion here we reject the null because p-value is lower than a reasonable significance level. And I might just compare and again, usually you're given the significance level or it will be very, very obvious, but otherwise just make an educated decision and explain that decision. Okay, so if I decided to reject the null, that means that I believe there's there's sufficient evidence that the proportion of men who would prefer to use the restroom during the game then Ms. Commercials is different than the proportion of women who would do the same. And I don't want to retype all that. And so I'll drag that down a little bit so you guys can see it. Okay. Now, more on the p-value. So our p-value is what led me to that decision. I said 0.04 is too low. Well, what does that 0.04 represent in the context? That 0.04 is saying if there truly isn't a difference between men who would prefer to miss the game and women who would prefer to miss the game, then there's a 4% chance that I would see a sample difference. And what sample difference did I see? Well, the sample difference I saw was this right here. I saw that in these samples, men were 6.4% more willing to miss it. And so the chances of me seeing a sample difference of 0.064 or more unusual. So there was a 4% chance of me seeing that. And I said that was too unusual. Okay, create a 95% confidence interval. To do that, we're just going to plug in x1, n1, x2, n2 into our calculator. I'm going to assume you know how to do that at this point. And you could just go ahead and check your answers. You should end up with about 0.25% and about 11%. So we see here I'm 95% confident that the true difference in the proportion of men and women is between 0.25% and 11%. And that would be how you would interpret that confidence interval. All right.